Okay, kids, here we go. We are working out our honors geometry area review for our test. So this first one says find the area contained between the three circles each with a radius of 10. So I am looking for this piece of information right here. That is not a normal shape, so I'm going to have to do a little bit of subtracting. Since the radius is 10, the hint was that it will need to connect all the centers of the circle. That makes an equilateral triangle. So let's draw this triangle right here. Each side of the equilateral triangle is each radius doubled, so it's 20, 20 by 20 by 20, and each angle is 60, which we already knew. But to find the area of the shaded part that I just drew in, I'm going to have to take out this piece right here, which is a sector. Remember the area of a sector? Well, I guess we'll go over it in a minute. But let's think. The radius of each individual circle is 10, so that goes here. This degree, which I wrote right here, is 60 because it's an equilateral triangle. So now, let's do some math. Drawing your height of your triangle, because it's base times height divided by 2. That's 60, that's 30. Which means our short side is the altitude. Or sorry, our short side is this piece down here, because this gets cut in half. So this would be 10 root 3. The area of the triangle would be 10 root 3 times 20 divided by 2, which is going to end up being 100 root 3. Cool. So now I have to take out the sector. Now remember, there are 3 of these sectors, but I'm just going to find the area of one. So first, figure out your fraction, which is 60 degrees out of the entire 360 in the circle. Let's reduce that. 6 over 36 is 1/6. Then I multiply that by the area of the whole circle, because I only want 1/6 of the circle. So I have pi r squared, pi times 10 squared, which is going to be 100 pi over 6. Remember, this piece is over 1. So that's the area of 1. I'll take that and multiply it by 3, because there are 1, 2, 3 of them. So I have now 300 pi over 6. And that can be reduced. 300 over 6, they both divide by 3, they both divide by 6. So I would have what, 50 pi? And then most of the time, as you well know, we're looking for an exact answer. So my answer would just be 100 root 3 minus 50 pi. There really is no way to combine those two together. Find the approximate area, approximate meaning it's going to be a decimal, area of a 40gon with a radius of 16 or 6. So I'm not going to draw a 40gon, but remember, whenever I find the area of a regular polygon, I divide it up into a bunch of triangles that are all the same. So here's what the triangle would be. And remember, technically there's going to be 40 of these triangles that are all going to be the same. So first off, a radius being 6. The radius being 6 is not the apothem, because that's from the center to the edge. The radius being 6 would be your slanted sides. This is not going to be a 30, 60, 90 or a 45, 45, 90. I'm probably going to have to do some trigonometry. So let's figure out what this big angle on the top is going to be. Remember, all of these triangles are around a central point. So that means that I can do 360 divided by 40 to get the angle on top. So 36 divided by 4 is 9 degrees. So the angle on top is 9 degrees, and that would be 4.5. So I got to find the apothem, and I got to find the side. Well, I'm actually technically finding half the side when I do trigonometry. So I'll find the side first. So that I would say is a sine. Sine of 4.5 equals s over 6. So when I pop that in my calculator, I'm going to do 6 times the sine of 4.5, which ends up being 0.5 0.47. So that's that piece, that's also that piece. And then you have to do the cosine to figure out the apothem. So the cosine of 4.5 equals the apothem over 6. And multiply both sides by 6. So this ends up being 5.98. So from here, you can do a couple different things. You can find the area of this triangle and then multiply it by 40 because there's 40 of them. Or you can do your 1/2 apothem times perimeter. This side is 0.47 times 2. Which is 0.94. Which means my perimeter would be 0.94 times 40, which is 37.6. And then my apothem I just found is 5.98. So if I do 5.98 multiplied by 37.6 and then divide that answer in half, I will get my area of my polygon, which I'll write down here because I ran out of space, 112.424 centimeters squared. And there we go. In theory, you should get the same answer no matter which way you do it. Okay, so if the base of the parallelogram is increased by 4.45% and the height is increased by 24%, how does the area change? So to do this, there's a couple different ways you could do it. This is talking about a really general case. So there's a lot of different ways to approach the problem. So here's my parallelogram. Here's my base and here's my height. So my area right now is base times height. So then if I think about percentages for a minute, which is flashing back to Algebra 1, I'm taking the base and I'm multiplying it by 0.45. And then I'm taking the height and multiplying it by 0.24. Now, technically, when you evaluate a percentage, you take this number and then you add it onto your original amount. So you could do that, or you could just multiply by 1.24 and 1.45. That's like saying you're doing 124% of the height and 145% of the height. It's basically the same thing. So if I do base times 124 and then the height times 1.45, really I only end up multiplying the 1.24 and the 1.45. I end up with 1.798 base times height. So that right there is how much bigger the area is than the other one. So if we're just talking about a straight percentage of increase, you would say it increases by 79.8%. And there's a lot of other ways you could do this. You could say that you could pick some random numbers and then take percentages and then notice that your percentage is increasing by almost 80. There's a lot of different ways to approach it. Okay, a rhombus has a perimeter of 68 and an angle of 44. What is the approximate area? Again, keyword approximate. So we're making an estimate. So let's draw a rhombus here. Perimeter of 68. A rhombus has all sides the same, so 68 divided by 4 is 17. So each side of this rhombus measures 17. And then we'll go ahead and we'll draw in our diagonals. I did not draw a very good rhombus, but remember, inside a rhombus, the diagonal is perpendicular, which is key. So one of the angles is 44. It doesn't matter which one you label as 44 degrees. when you draw in the diagonal, that diagonal is getting cut in half. Now you can do a little bit of thinking. If you really wanted, you could figure out the other angle inside that, and you could say, 90 minus 22 and figure out that piece. But you actually don't need to, because you need to find like this piece here and this piece here. We'll call that A and that B. We can even draw the triangle over here so we can see it a little better. A, 22, and B. And you know that this is 17. So you're going to have to use trigonometry. Let's do the sine of 22 equals B over 17. And we'll also do the cosine of 22 equals A over 17. And after we do some math and we punch that into our calculator, we end up with the cosine, or 17 times the cosine of 22. Which is 15.76. And then 17 times the sine of 22, which is 6.37. Now, why did I find those two pieces? Because the formula for the area of a rhombus, you could do base times height, but you can also do diagonal 1 times diagonal 2. So diagonal 1 is A times 2. That's a 15. There we go. So 15.76 times 2, which is going to be 31.52. E2 is 6.37 times 2, which is 12.74. So if I do multiply these two and then divide by 2, 31.52 times 12.74, and then divide that by 2, and I get a little over 200, 200.78. And we'll stop this video and we'll start a new one for the next batch.